Here is a reaction equation showing two half reactions. Let's balance this reaction. First we'll do it by the acidic method, and then we will expand that to the basic method. The first thing we need to do is determine what's being oxidized and what's being reduced. In order to do that, we will look at the oxidation numbers. The reason that we are finding the oxidation numbers is we're going to need to split this into two half reactions, so we need to know what's been oxidized and what's been reduced, so we can split them into the proper half reaction. So let's start over here with nitrous acid. Since there's no charge written here, then the charge of nitrous acid is 0. So all of this must equal 0. When finding the oxidation state, you have to remember the priority list. So metals always get highest priority. There's no metal in nitrous acid. Next on the priority list is hydrogen. So hydrogen will get its ionic charge because it has the highest priority in this molecule. Next on that list is oxygen. Oxygen will get a -2 charge. And so now nitrogen, being the lowest on the priority list, has to make up for the charge of the other one so that the total charge of the molecule is 0. So you can write this out algebraically if you want. So 0, we have a -2 for the oxygen, and there's 2 oxygens. There's only 1 nitrogen, so we'll give that an X, and then there's 1 hydrogen with a +1 charge. If you solve that out, then the charge of the nitrogen is going to be a +3. So we can do the same thing. I'm not going to write out all the steps for the rest of these, but if we look at this germanic acid, hydrogen will get the first priority. This is a semi-metal, so it will get really low priority. Okay, so the hydrogen will get +1, the oxygen will get -2, and then the germanium is left to make up the difference. The total thing has a charge of 0 because nothing is written. And so if you write out the algebraic equation, you would see that germanium has an oxidation charge of +4. Over here, germanium is all by itself. There's no charge written, so we know it has an oxidation state of 0. And lastly, with nitrate, this one is a little bit different because we have a charge on the whole thing written right here. So this whole thing, if you wrote it out algebraically, would not equal 0. This time it would equal -1 because we have a charge written with it. And this one, oxygen, has a -2 charge, so we have -2, and there's 3 of those. The nitrogen has the lowest priority, so that's the one that's going to compensate for the oxygen. So in this case, the nitrogen will have a +5 charge. Okay, so the purpose of writing out all of those oxidation states is that we can identify what's been oxidized and what has been reduced. So first we can go through and identify what has changed. The hydrogen is +1 here, +1 here, not even hydrogen over there, so that can't be it. Okay, the nitrogen has +3 over here and +5 over here. So this has changed its oxidation state. This has undergone either oxidation or reduction. We'll talk about it in a minute. The oxygens are the same in all the spots, and the germanium has gone from +4 to 0. So the nitrogen has gone from a +3 charge to a +5 charge. If it's gaining charges, it's becoming more positive. That means it's losing electrons, and losing electrons is oxidation. The germanium, on the other hand, went from +4 to 0, and meaning it's gained electrons because its charge is becoming more negative, and gaining of electrons is reduction. When we have oxidation, this will happen at the anode, and when we have reduction, this will happen at the cathode. Okay, so what's next then is you are going to take these species that have been oxidized and reduced respectively and split everything associated with that species into separate reactions. So at the anode, everything that has nitrogen in it, this is getting really messy, but everything that has nitrogen, so this nitrous acid and this nitrate, will be at the anode, and then everything that has the germanium in it, we will write at the cathode. So once you've determined what's oxidized and what's reduced, we'll split those into those two reactions, and then we just have 6 steps and we follow them, and it's one of the really rare times in chemistry where you literally just check off a checklist. Just follow these steps in order and you'll have a balanced reaction at the end. The first step is to balance everything except for hydrogen and oxygen. Here, the only thing that's not hydrogen or oxygen is nitrogen, and that's already balanced because we have one on each side of the reaction. So we can check off our first step. Moving on, step 2, balance the oxygen by adding water. So here we see we have 3 oxygens on the product side, and we have 2 oxygens on the reactant side, which means we need more oxygen on this side. The only way to add oxygen into the reaction is to add water. So we need 1, we add 1 water. And then we can check that off our list. Next up, balance the hydrogens by adding hydrogen ions. So we look at the total number of hydrogen on both sides. So I have 3 over here on the reactant side. I don't have any on the product side, which means I need to add 3 hydrogens over here. The only way to add hydrogen is by adding a hydrogen ion. Check. Moving on. Step 4, balance the charges by adding electrons. This is the part that is probably more often confused than the other parts. So you want to look at the total on the reactant side of the total charge. Here, since water and nitrous acid are both neutral, our total charge is 0. Then we look at the total charge on the product side. We have nitrate with a -1 charge and 3 hydrogen ions with a positive charge. So 3 plus minus 1 gives us a total charge of +2. We can only balance the charge by adding electrons, which have a negative charge. So you're always going to go to the side that is more positive and add as many electrons as make it the same as the other side. Since +2 is 2 higher than 0, we just need to add 2 electrons to make this electrically neutral. Now we have a balanced half reaction at the anode. And we're going to go check this off our list, and then we're going to repeat steps 1 through 4 at the cathode. So step 1, balance everything except for hydrogen and oxygen. The only thing that's not hydrogen or oxygen in this one is germanium, and again, that's already balanced. So we can move on to step 2. Step 2 is balance oxygen by adding water. So we have 3 oxygen here, and we don't have any on the product side, so we'll need to add 3 waters to give us 3 oxygens. Step 3, balance the hydrogens by adding hydrogen ions. On the reactant side, we have 2 hydrogens. On the product side, we now have 6 hydrogens, which means we need to add 4 hydrogen ions to balance this. And in step 4, we're going to balance the charges by adding electrons. So the total charge right now on this side of the reaction is +4, since the germanic acid is neutral, the hydrogen ions are positive. And over here, the total charge is 0, since the germanium and the water are both neutral. So we add the electrons to the more positive side in order to have the same number as here. So that means we need 4 electrons over here. Now at this point, you can always stop and check your work. Remember, reduction means we're gaining electrons. So we should have the electrons on the reactant side, which we do, so that's good. When we look at the anode, we're oxidizing, which means we're losing electrons. So those should be on the product side. They are, so that's good. We need to make sure the electrons are on opposite sides of the equation at this point, otherwise we're going to get in trouble when we try and combine these. All right, step 5, we are going to make sure that the number of electrons is the same for our half reactions. So at the cathode, we have 4 electrons. At the anode, we have 2 electrons. Since those aren't the same, we need to multiply the equations until they are the same. This one can be easily fixed by just multiplying the anode by 2, which means we're going to multiply everything in there by 2. Okay, so now that our electrons are the same, we can go to the final step, which is combine our half reactions and simplify. So I've rewritten them here. What we're going to do is we're going to take everything on the reactant side and we're going to combine those together. This is going to react to form everything on the product side. At this point, we can go through and simplify to see what cancels. Now, at this point, the electrons must absolutely cancel. If the electrons don't cancel, then you've done something wrong, because in a balanced oxidation-reduction reaction, you shouldn't see the electrons. And then we'll look for other things that are similar. We see here we have water on both sides. Since there's 2 over here, both of these will cancel and 2 of these will cancel, leaving us just 1 water. And a similar thing is happening with the hydrogen ions. So these ones will cancel, leaving us with 2 hydrogen ions on the product side. That leaves us with nitrous acid, germanic acid, nitrate, and germanium. And since those are it's all the same elements as it should be, because it's going to be a balanced equation, but they're showing up in different species, so they don't cancel. So then we can rewrite the equation with our simplified version. Okay, and then once you have that all put together, you can always double check. So I'm going to give you 2 ways to double check. The first way is it should already balance. If it's not balanced, then you've done something wrong. Okay, so we have 2 4 hydrogens here. We have 2 4 hydrogens here. We have 2 nitrogens here. We have 2 nitrogens here. We have, let's see, 2 times 2 is 4 plus 3 is 7 oxygens over here. And then we have 6, 7 oxygens over here. And then just 1 germanium on both sides. So the elements balance, check. The second thing that you can look for is that the charges are balanced as well. So both the elements and the charges need to balance for this to be an accurate equation. So we can check and see if the charges balance. Over here, both nitrous acid and germanic acid are neutral, so this is 0. Hopefully everything on the product side cancels out to 0 as well. Water and germanium are neutral, so those are 0. We have 2 protons with 2 positive charges and 2 nitrates with 2 negative charges, which sum up to 0. So our charges balance too. So we can be confident that we've written a balanced equation. The last thing is, if you wanted to balance this in a basic medium instead of an acidic medium, you would do everything the same. And then you'd add 1 extra step, which is finding the number of protons and adding that number of hydroxides on both sides of the equation. We already have a balanced equation, so whatever we do to one side, we must also do to the other side. I'm adding 2 because I have 2 protons over here. And then we'll combine the hydrogen ions and the hydroxide ions into water and just leave this hydroxide on the reactant side as is. So now I have 2 nitrous acids, 2 hydroxides, and a germanic acid reacting to form 2 nitrates, germanium, and it's going to be 3 waters. So if you can see, this 2 hydrogen and 2 hydroxide makes 2 waters, and then I already have a water here, so that would give us 3 waters over here. And that would be the balanced equation by the basic method. And that's it.